TechTalk.com. Welcome once again. This is now Physics 2. We can continue from where we had stopped. And now we come to something very interesting once again. And that is refractive index. Refractive index of smaller quantity of a liquid, isn't it? And now here we are going to first basically look at the expression for the refractive index of smaller quantity of liquid. And then we shall first look at using a concave mirror. We are first going to look at the expression. If I would say, we're going to first determine the expression. So, how do we get the expression for smaller amount of liquid? I will draw this diagram here and I exaggerate it. So, if I have that as my liquid, this is the principal axis. So if I have this as my object, so as image, I have this will happen like this. This will be refracted there. Like this. There's refraction there, please. So this one like that. And then this will appear like to be coming from here. Okay? And now this one here will strike here at 90. And then what is very true is that if we call this is the depth of the liquid, so this one here can be our angle I, and this one here angle R, and then this depth here can be equivalent to D, and this height here is H. And then from here, if we are to extrapolate, and we call this distance here as R, this is object and this is the image I, this is C, this is N, M, P, something of the kind. So I will now use that diagram there to derive the expression. So this angle here will be equivalent to I, and this angle here will be equivalent to R. If you look at it properly, if this is I, the angle of incidence to this point, and then I mean this is also the same because it is something like this. Okay? If I have this I, this one can be I. If this I, that can be I. Same thing to this. If you have something like this, if this is R, this should be also R. R should be R up there. So, I don't know if people are getting that right. That if this is R, angle of refraction, the same angle is up here. They are corresponding angles. they are the same point, like I've been saying that this is a straight line up here, like this. This is R, therefore this can also be R. And then for I, something like this, using instead this, that if this is I, even this is it, okay, R. So that is that. And then I can now say, applying Snell's law, at any, we shall say refractive index of air, sine of angle in air, to be equal to refractive index of the liquid, sine of angle in the liquid. Okay? And then I'll say from my triangle, any, this is object, I can call this point A, and then I can say this is object, and then I say this is image. Is that okay? So I can say from triangle any A M, from this triangle here, sine of I equal to opposite of hypotenuse of any A. And then from triangle any CM, sine of R equaling to opposite, from this triangle here, opposite of hypotenuse of any C. Okay? And then if I try substituting this back there, we're going to say refractive index of air is 1 times sine I. Sine I is the same as any MO out of any A. And then should be equaling to any LR times sine R. But what is my sine R? Is any MO out of any C. So you realize that this one and this one can excuse us. And then I make NL of the subject, the refractive index of the liquid, to be now equaling to any C over any A. So we're saying refractive index of the liquid is equaling to any C divided by any A. And then there we can now make an assumption by saying that for smaller angles of I and R, that when we are looking at smaller angles of I and R, what is very true is that point N will be too close to point M. If this angle, we are assuming that it is reducing a very small angle, like imagine if we decide to make I to be an angle which is maybe just here, you realize that this point N here will now be very close to M. We shall say that any point N will be close to M such that if now this point is very close there, so that we can now take CN to be approximate, we're saying approximate, not equal but approximately, that if this point now I look at it, I being a smaller angle, in that now it is maybe striking here, and now I have N here, point where it is striking. Yeah? So that means that C, this will appear to be coming from some point C, and then Cn can be taken as Cm. It can be now taken to be, Cn can be taken as approximately, not the same but almost the same, equaling to Cm. And again, what is very true is that An or any A will approximate to what? Am. Okay? It is an assumption that we are dealing with smaller angles of I and R. And if we are saying if those angles are too small, what is very true is that this point here, if you reduce the side of I to a very smaller angle, you realize that point N is shifting close to point M. So if that is happening, that N is coming close to M, it means this distance can be just taken as this. And then this distance will be taken as that. So it is just an assumption that you should make. It is one of the marking point. So if that is very true, we are now going to say that my NL is now NC. But we say the NC, or what we call it CN, is the same as a CM divided by now our NA, but NA is the same as the MOA. Okay? It is the same as the CM over AM. And what is the CM? CM is the same as now R minus D. That is R minus D. Out of AM, AM is the same as H minus D. And this is our expression for refractive index of the liquid. Okay? And then you should also say that, we should also note that if the depth D of the liquid is too small, that if we are looking at the depth of the liquid is too small, okay, and then point M is close to point P, that if the depth of the liquid reduces, we are looking at it, if we use a very small amount of the liquid, like maybe say just something like, what is very true that the point here at M will now be like somewhere here, and now that is very close to point P, such that we can now say our CM is approximately CP, and the AM will approximate to AP, and then we shall say our refractive index CM, which is the same as CP, out of AM, which is the same as AP. But what is CP? CP is R out of AP is H. So in other words, the refractive index will be R out of H. This formula is only right if they say the depth of the liquid is too small. So it is like saying that if the depth of the liquid is too small, it is approximately 0. It's like taking this one to tending it to 0, taking this one to 0, so that the formula is R out of H. But we need to make some assumption that should be shown with that. So it is either this or this. So therefore, we can say that if the depth of the liquid cannot be neglected, okay, the formula is R minus D out of H minus D, where R is the radius of curvature of the mirror, because we said that if we draw any line that is coming from the mirror and it is normal, and it is so happen that the line is extended to cut the principal axis, it will cut it at the radius of curvature. And then H is the point of coincidence between the image and the object, and then D is the depth of the liquid. So this is an expression for refractive index of smaller quantity of the liquid, and we are basically looking at concave mirror. Let's look at the next part in the next episode.